on this episode of Science.
Hello, and welcome to this special edition of Science. I'm Nate Macon, and I'm a physics teacher at Skyview High School. Today is our SMT Challenge Day, an all-day, school-wide extravaganza of science and ingenuity. The goal is to bring out the best in our students and their ability to problem solve as a team. The kids have just one day to design and fabricate a solution to a complex problem. Every year we have a theme, and this year it's Batman. Let's see what they're up against. To the Bat graphic!
Now in our scenario, the Riddler and the Penguin have kidnapped Gotham's army and stranded them on an island. Our students have to come up with a device that will swoop in, pick up the soldiers, and drop them off safely back in Gotham City. We replicate that in the commons here at Skyview High School. A table near one end represents the island, and on it are the army figurines. The students have to build a device that can ride down a zip line and will pick up as many soldiers as possible. Here's what they'll have to get it done. 8 pipe cleaners, 1 mousetrap, 2 clothespins, 10 rubber bands, 15 paper clips, a shoebox or cardboard, 3 plastic knives, a ½ meter of duct tape, ½ meter of string, a propeller, 10 pages of construction paper, 6 twist ties, 10 drinking straws, 1 plastic bottle, 1 action figure that they bring from home.
Now the real objective of this challenge is not to rescue a bunch of toy soldiers. It is to use creativity, scientific principles, and teamwork to solve a difficult problem. My goal is to get the kids to realize problem solving, no matter how difficult, can be entertaining and fun. Now the students are already in motion. Let's go check in on their progress.
The first step is to assess the tools you have.
Some knives, some twist ties, propeller, mousetraps.
Then, figure out what you need to do with those tools. I wrote an illustrated comic book with all the instructions so the students would not only know the story, but also the basic dimensions of the space in which they would need to work. It's up to them to compute the angles and speed.
Do you know how steep the slope is?
No. We can do math to try to figure it out.
Yeah.
So right here is 3 meters.
Yeah.
Okay, so we can find this triangle. This
I don't think we need it anymore.
We don't? So
No.
this is 3?
We just need to make it so that it picks up something in 3 meters.
Okay.
So lunch table is 73. 73 centimeters, so 0.73 meters.
We don't know how long this line is right here.
He's got a 2-pack.
This one, let's use a squared plus b squared.
Once the math is done, they have to design their device.
Edge of the table. Is the soldier going to be here or like?
I think the soldier's going to be on the top of the table, and we have to I think it's like scoop off the table.
Okay, we need to like fasten.
Wait, do we pick him up?
Yeah, make a scoop.
You can do like a dog scoop or whatever. You go like that, and it's gonna scoop up the army men, and then at the end, it's gonna probably hit something at the end, I'm guessing, and it's gonna drop off the army men in the same position.
That's not gonna work. It's too flimsy. You got folded
And then you like
stuff.
put straws on them.
Yeah.
Okay.
That's a good idea.
That's even tinier than the one. Hi, Gabriel.
I have bionicle jack.
It's a little bit bigger.
Are you using your big hand?
You know? So too. That hurt.
They have to think about variables.
Do you guys know how big the zip line is? Like how thick the line is? Is it just like a piece of string?
No, but if we use a paper clip, we can make it bigger.
One of the biggest challenges for all of the groups is working as a team.
This is my first time doing the SMT challenge, and I think it's actually really cool. It kind of brings a lot of people together. Like, even though our team's all freshmen, it kind of shows like different people's personalities and how people react with different people's ideas and stuff. It's a lot of fun, and I think it's really cool.
Well, I think it's like where we all come together, and just try to solve everyday problems, It's more like real life problems, real life situations that could probably happen, and who knows, we might find a way,
They have to not only work together, but also build something that actually functions.
We're not very far into it, but I think it's really hard. Yeah, me too. Yeah.
Now, once their plan's in place, it's time to build. Using the items on their list, students are going to find out if their ideas will actually work in real life.
Like what if we twist this rubber band up and the second it goes, it'll start unwinding, it'll drop something, and then which will trigger the mousetrap to flick something.
We're having a water bottle, and we're just gonna send Batman on the water bottle. We have paper clips that are hooked onto them that hopefully will pick them up.
Now, once their plan's in place, it's time to build. Using the items on their list, students are going to find out if their ideas will actually work in real life.
Pipe cleaners are better because it's more sturdier. So it keeps it like, if we do string, it just doesn't work. Trust me, it doesn't work.
I think it's important because kids need to feel like what they're learning in the class day to day is applicable anytime. They get to build, have fun, work as teams, and use those things that we're trying to teach them, within a small classroom setting in a different kind of way.
I think that we should extend the string then, because this needs to be on like this.
Yeah, we'll work our way up to that.
Okay.
Once the basic construction is done, students run off to the test areas. I am creating the test zip line. This is a kind of a mock-up of what our final zip line is going to look like, so they can take their products that they make here and hopefully just try them out here to make sure that they got proof of concept to see if they work.
Ready? Freedom!
As groups work their way through long lines and actually give their device a whirl, they find out that the weight plays a major role.
The weight was too high and the tension on the string was too low for it to be going at enough velocity.
Oh, dude, we didn't even get. I think this ramp right here is too
Yeah.
big.
Time to tear the ramp.
Trial and error.
The students had to adjust their weight of their device, their scooping mechanism, and how their device attaches to the string.
The kids are excited. They're trying out their ideas. It's fun to see them go through that trial and error process.
It's either like you got to have the perfect amount of weight and speed, or you fail. You didn't get any.
Dude, we'll just add a little bit of weight to the back and we're set.
Well, our first test wasn't very successful. We only picked up one army man and got him there successfully, but we were very far from finishing, so I think we can probably get it done.
Yeah. Ready?
Some groups' adjustments were very successful. Some, well, not so much.
My group, we started out trying, and then we failed. Then we took a little break, got a new idea, and then it failed. So we're just trying to get points now.
The main way to get points is to scoop soldiers up once the competition starts. Another way is to make adults in the room laugh.
3 guys get on 3 separate planes. The first guy decides to spit out. When he lands, he sees this little girl crying. He goes, "What's so wrong?" "No, what's the matter?" She goes, "Somebody spit and it landed on my head." The second guy takes a stick and throws it out the window. When he lands, he sees a little boy crying. He goes, "What's the matter?" "Somebody threw a stick and it hit me on the head." The third guy takes a grenade, pulls the pin, and throws it out the window. When he lands, he sees an old man sitting in a crater laughing. He goes, "What's so funny?" The old man goes, "I flushed the toilet, my house go boom!"
Like the devices, some jokes were more successful than others.
So we're going to take a lunch break. So should you. And maybe while you're eating lunch, you could learn about today's famous scientist.
Today's famous scientist is a true American innovator, Philo Farnsworth. He was born in a log cabin in Utah in 1906. In his lifetime, he helped usher the world into the electronic age. When he was just 14, Farnsworth began to sketch out ideas for his most important invention, the first electronic television. He was a farmer's son, and from his father's plow in the field, he got his idea of a screen full of scanning lines going back and forth. Farnsworth had a working prototype of the TV at the facial hair growing age of 21. A bright guy like Farnsworth knew what his invention would mean. His first image that he broadcasted was a $sign. And everyone wanted a piece of his priceless idea. Farnsworth and RCA spent years in court over the design of their competing television systems, but Farnsworth came out the winner. In the coming years, from his basement laboratory nicknamed the Cave, Farnsworth's discoveries would improve upon or completely invent things like radar, infrared night vision, the electronic microscope, and the baby incubator. Oh yeah, he also invented a device that creates a little thing we call nuclear fusion. In all, he racked up more than 300 patents in the U.S. and elsewhere. Amazingly, despite being the man most responsible for the development of TV, Farnsworth appeared on it just once in the 1957 game show, I've Got a Secret.
Now, we're not going to identify this contestant panel because to identify him would be to tip off his secret. We will call him simply Dr. X. Now, Doctor, if you will whisper your secret to me, we will show it at the same time to the folks out there.
He stumped the panel, and for that, he won $80 and a carton of cigarettes. Incredibly, on that appearance, Farnsworth also predicted the invention of high-definition TV and DVRs. Long after his death, his wife said the moment Farnsworth knew he had invented something important was when he saw Neil Armstrong land on the moon in 1969.
It's one small step for man.
Before that, his wife said, he wasn't too sure.
One giant leap for mankind.
Of course, that was a long time before Jersey Shore and this show came on the air. From a log cabin to broadcasting from space, Philo Farnsworth helped shape the world in which we live. I'm sure that wherever Philo is now, he's really sorry for that whole Jersey Shore thing.
So now we're back from lunch. And the kids have been working really hard. We've seen the practice zone where all the students have actually been testing out their devices to see if the concepts actually work. But now we've gone to the trouble of actually making the real test zone, which as you can see is much bigger.
Just like building devices was a challenge for students, building the competition area was tough for me.
That looks good.
I have to make sure that the dimensions are spot on, measuring distances and angles, just like the students. Batman had his Joker, and my arch nemesis, well, this time it was string. Once we got it untangled, the students split up. Half their group members on the top to send off their devices, and half them at the bottom to receive them.
You get to go as many times as you want!
And after hours of planning, construction, and testing, it was bombs away.
Boom.
What worked perfectly in the testing area is not working in our competition.
Too heavy. They're all too heavy.
Now, like any good engineer or any good scientist, the best groups started making adjustments, lightening their load, changing their scoop mechanism.
If there's a will, there's a way, you know.
And just like that, our first success. This triangle-shaped vessel is built just right, so it maintains its balance, comes down at a good speed, and has a scooping device that gathers the soldiers and keeps them there.
26. How'd you 26, you guys get your scorecard?
Riley has it. It's up there.
Okay, tell him bring it down so I can write 26 on it. That was awesome, guys.
Some groups continue to struggle with the weight, either getting their device to the table but no farther, or getting their device stuck on the line. Others do a great job with the weight, but have faulty scoops that end up dumping the soldiers off the edge of the table. As the competition wears on, it's clear which designs are the best. This red scoop is successful time and time again, combining the right mix of balance and speed with a sturdy front end. Other, similar designs also get the job done.
Yes, we got one!
We got one!
After a couple hundred attempts, the students gather back in the auditorium to find out who won. The winner, as you can see, is the team that built the triangular device.
And they got one of the most creative. That front part, pretty creative.
The group scored 26 points, the most of any group. And most importantly of all, they used teamwork and problem solving to find a way to complete a nearly impossible task. Here's today's mailbag. Tony writes, Mr. Macon, in the last episode you played with fire. Have your eyebrows grown back yet? Yes, Tony. In the last episode we did build a Rubens tube, which used fire to demonstrate how waves work. And this may surprise you, but my eyebrows survived intact. The downside to the whole experiment, though, was that my classroom smelled a lot like hot dogs for a week. Although, that may be an improvement from its regular smell. If you have a question for me, science-related or not, email me at scienceshow@vansd.org. If your question isn't terrible, I might read it on the air.
So here's the point. Problem solving is a learned skill that is fun. It happens all the time, whether you're fixing a car, playing a video game, or putting up with relatives that just won't leave. Uncle Frank, I'm talking to you. No one cares about your stamp collection. Anyway, I hope you enjoyed this special edition of Science. And remember, you can always see more science at youtube.com/VanSDTV. I'm Nate Macon. We'll see you next time.
How many people does it take to untangle a knot? Apparently, 3.